I have a start webinar button on my screen. Should I push that?
I just did.
Okay. Yeah, and it disappeared. Okay.
Well, welcome. Good afternoon or good morning or good evening, wherever you're coming from. It's going to take a while for everybody to come in, so we'll give them a couple of seconds to get in there. And we'll get started when the number of attendees starts to level off. Okay, they're still coming in. All right, while we're waiting for a few more people to come in, my name's Miles. I'm the Senior Cloud and DevOps Advisor at ExitCertified. ExitCertified is partnered with AWS for training. Training is kind of our only business. We've been doing AWS training, authorized training since 2014. So, 9 years, coming up on 10 soon. And yeah, it looks like people are still coming in. So, it takes a little while on these Zoom webinars. By the way, this is sort of a one of these kind of free webinars that we put on. So it's a little bit different than our regular classes. We want to open it up to as many people as possible. We had well over 100 people register. We never get quite that many people show up, but so we run it more webinar style. So you can't turn on your cameras or your microphones, but you should be able to ask questions in the chat and see the questions asked. So let me just throw something in the chat here. Hello from Toronto. That's where I'm from. Maybe you can throw in the chat where you're coming from. Pete is going to be your instructor. He's a fellow Canadian. Where you're somewhere near Ottawa, right? Oh, Prescott. Yeah, that's, well, somewhere near Ottawa. So we'll see. Oh, here we go. We got New Jersey. All right. So people are still coming in, but so these we do these a little more webinar style. Just to answer some things up front. The slides that Pete is using, he's not allowed to share with you. But we are allowed to record this, and so everybody who registered will get an email with the link to the recording. In fact, this is just one of a series of discovery days that AWS allows authorized training partners like ExitCertified to produce. So we have 2 more live ones. So next Tuesday, I'll be doing one on data and analytics. And then the following Tuesday, our colleague Chris Littlefield will be doing one on machine learning. But there was a couple that already went by. So when we come back at the end, I'm going to leave and sort of just deal with the chat. Pete's going to present. And then I'll talk a little bit at the end. We've got like a summer promotion going on. If you want to take any technical training, you can get a pretty good deal on that. We also have, some other, we'll probably talk about some of the courses. And I'll also point you towards some of the other free webinars and where you can find those. But for now, I think without further ado, I'll introduce Pete Durst. Pete's been in IT for a very long time. I met him in the late 90s, I believe. We both worked at the same company where he was a Solaris administration kind of guy, and I was more of a Java developer. And so, we've sort of mirrored our jobs along the way. He more on the administration side and security, and me more on the development and data and analytics side. And so we've worked together at several different companies, and there's nobody I would rather be in a class with when it comes to all things security, especially in the cloud, because like myself, Pete's been, teaching AWS classes since 2014, somewhere around there. So you're in very good hands. So Pete, take it away.
All right, thank you, Miles, and welcome to the Discovery Days class. I'm Pete Durst. I'm going to be the person dragging you through some slides. I'm a solutions architect specialist, and DevOps engineer, security specialist, and a network specialist with AWS. So that's a number of certifications. Certainly, I play a lot in the secure world, and as we all know, security is an evolving, ever-changing environment. There is no consistency to any of it because, as we know, those evildoers on the planet are out there looking for ways to, make your life a little bit rougher than it should be. So what we want to do is talk a little bit about security in AWS and looking after your resources in the cloud. And of course, introduce you to some of the things that we do to help you out, as well as introducing some things that you may not have been aware of, and hopefully they can help you when you're trying to protect your resources and your data, of course. So let's go ahead and get started and look at the benefits of using the cloud. So the first thing off is, cloud environments allow for you to step away from a management of a data center where, you have physical limits. You only have so many slots in the racks, you only have so many racks, only so much power, cooling, and so on and so forth. They become the problem. They become a fixed, issue. You can't really, defeat that. And of course, the long procurement times and everything else also worked against the data centers. And certainly, many of the reasons for folks to move to a cloud-based solution is those ones there. With the cloud, benefit of elasticity to be able to change things quickly. In other words, be able to move from one type of system to another one, or experiment with new technologies, or look at, different approaches is relatively easy. We've got, lots and lots of choices, and the opportunities are there for you to take advantage of that. And of course, being able to increase or decrease your fleet sizes to accommodate load, testing, whatever, is always a big piece to that. Speed and agility is part and parcel to that, being able to change quickly. Your customers are, speed freaks. They want things quickly. They don't want to wait for months or years to get new features. They want them yesterday. And of course, we know that. And this is all part of being, in a fast-moving, fast-evolving world, to be able to keep up with that. To be able to go anywhere in the world is also another big feature. I have clients in European area to be able to deploy my services in that area to reduce their latency, to reduce their time to wait for things to happen. Of course, increase the performance for downloads and things like that. That's super important. We trade off the purchase world to the pay-as-you-go or the rental world. So instead of buying your car, you rent it. And just like renting a car, when you're done with it, you turn it back in. You stop paying for it when you give the keys back. So this is exactly what we do. You rent your compute resources. When you're finished with them, you return them. And of course, you stop paying for them at that point. We want to also have a very secure environment. So not only AWS helping you to protect your resources, but you being able to do all those things that you already know how to do, and do that in a way to, again, help protect your resources, prevent those evildoers from winning. And that's always something we want to be very, very much on top of. It's just not a one-time thing. You got to do this continuously. So your account, in AWS, an account is the owner of the resources, if you will. When you create an AWS account, of course, you use an email address to do this. The email address, of course, identifies the account ownership, if you will. The account is given a unique number, and of course, we use that as a reference to who owns which resources where. Inside the account, of course, you can create users, regular standard users, and again, provide permissions to them to be able to manage those resources in the account, which could be things like the virtual machines, Elastic Compute Cloud or EC2, our storage solution called S3 or Simple Storage Service. And again, being able to manage those resources, plus many, many, many others that we have in our world. From the security perspective, we need to really identify, what the customer is responsible for and what, of course, AWS is responsible for. And that's really what, is super important to start off with. So when we look at this particular diagram, we see, AWS is responsible for everything below that dashed line. And if we look at this is all the hardware. So every data center that AWS owns, wherever they are, those are 100%, managed, and AWS is 100% responsible for those. The services they run above those, providing us access to those compute resources or storage resources or whatever they might be, that's also AWS's responsibility. So this is always 100% AWS. When we look above the line, this is where we get into, potentially what type of services to how much of this is yours. ultimately, the customer data is always 100% yours. Like AWS is never, ever responsible for this. This is yours. However, the intervening layers here really kind of depend on what service you're talking about as to whether that's going to be your responsibility or a combination of you and AWS, or even just AWS. So our simple storage service, pretty much none of this belongs to the customer. Almost all of this belongs to AWS. On the other hand, Elastic Compute Cloud, the virtual machine, all of this belongs to you. So it really kind of depends on the service as to how much of this is really going to be, your responsibility. And again, we look at things like, application updates and patches, operating system updates and patches, using encryption or not, server-side encryption, client-side encryption, VPNs, network protections. All of these things all fit into this area. And of course, these are super important, to keep in view. And again, it is above that line. So it's kind of one of those things to make sure that if you're responsible for it, that you're taking care of that. The security design principles are the next thing we want to look at. And again, we want to, kind of look at all the different things that we can talk about as far as security goes. And we'll start off with the principle of least privilege. So least privilege principle really is all about making sure that the users in your account only have enough privilege to do their job. And this may sound kind of, like we're handcuffing them and we're restricting them severely and stuff like that. But the other side of this, and you kind of look at it from the business perspective, is if I allow that person to have privileges to do everything, mistakes can happen. They don't maybe understand the billing mechanism. They don't understand the cost mechanisms. They go out there and they launch, something like Redshift, which is a very expensive data warehousing solution, and they're just playing around. They don't even realize that they're costing their company a lot of money with a resource that really isn't needed. And then the other side of that is accidents do happen. So, hey, I was over here looking at this resource. I didn't realize that if I said delete it actually would delete it. I'm sorry, I didn't mean to make that go away. What do you mean that was the production database that disappeared? So these are kinds of things where you really want to make sure that they just have enough to do their job. From my perspective as a security guy, I love calls that say, Pete, I can't do my job because I don't have the permissions to do what I need to do. And then I have to resolve that and figure out what I need to give them to let them do their job. I'd rather get that kind of call than the call from their manager which said, how come our production database disappeared? And why didn't you stop that? Which is always a call that nobody ever wants to have. So these are really the kinds of things that we want this to apply to. Least privilege principle, only enough to do what you need to do. Don't go any further than that. Enforce separation of duties. Hey, as a database admin, you need these privileges. As a developer, you need these privileges. They're not going to be the same. So, when you're working as the database admin, here's your privileges you need for that. And when you're working as the developer, here's your privileges for that. And we really don't want them to be mixed together and say, well, you need to do both, so we'll just give you everything in one shot. We really don't want to separate them out. So roles come into play, and we use those as a way to say, hey, when you're doing the database admin, use this role. When you're doing developing, use this role. Long-term credentials are where we have passwords and keys and that don't expire. And this is something that, it's convenient, but it's also what hackers love. And when we look at it from that perspective, you need to, make sure that you're using policies that force password changes regularly. You're using policies that force key changes regularly. If you're using roles, kind of what I was just talking about in the previous bullet, these always use temporary credentials. The credentials are max time is 36 hours, so they can't last longer than that. So that's really a great idea. Short-term credentials really mean that if they're compromised, somebody's gotten them that shouldn't have gotten them, they're not going to last long. They're not going to be much value to them for a very long period of time. Change them as quick as you can. Enable traceability. So whenever I'm doing a security engineering class or security essentials class, one of the very first things I tell people, and even in the architecting classes, is check your compliance requirements. You need to go and look up your compliance requirements. We have a service called AWS Artifact, which is a great place to go and look for this information. Find out what you have to work with. What do you need to do in order to stay compliant for the services that you're running? And almost always, I'm going to say 100% of the time, it's going to say you need to capture activity logs. You need to capture what's going on in your account. So enabling traceability is a big part of that. One sec here, I'm going to sneeze. Sorry about that. I thought I was going to sneeze. It's going to come back later. I apologize. So enabling traceability is all about capturing those activities and what's going on with the activity logs and stuff like that. So with that, CloudTrail is our API tracing tool, if you will, tracks all the API requests made in your account. So that's one piece to that. Application access and activity and stuff is something that you need to do. And that, of course, is capture the information from the host, from the virtual machine, for example, and then, of course, store that in some location that you can retain those for as long as you need to retain them. Take advantage of the services that can help you manage that information, be able to search for patterns, be able to look for things. And that, of course, the CloudWatch Logs service can help out. And of course, there are lots of third-party services out there as well. Keep an eye on what's going on with your resources. So another service is called Config, AWS Config. Keeps track of all your resources, when they were created, when they were last changed, when they were deleted. All that's recorded in there, so you can track resource existence. When did it come, when did it go, when did who made it go where through CloudTrail, et cetera, et cetera. So it's lots of things there. Secure at all layers. So we like to think of it like an onion, the layered approach. With an onion, you peel off a layer, you get to the next one, peel off a layer, get to the next one, peel off a layer, get to the next one. With security, having a layered defense just means there are many things that have to happen before that information becomes exposed to whoever's trying to get to it. Obviously, we need those that need to be able to get to it. So that's where CIA comes in, confidentiality, integrity, and availability. So the A piece of that is, being able to make it available. So how do I make sure that that data is available? It doesn't get compromised, it's integral. I need to do all of that. So putting many layers of defense into play is a fantastic idea. 3 firewalls is better than 1. 5 firewalls is better than 3. It's always in your best interest to put as many barriers between those that could do bad, nasty things to you and your sensitive information, the information you want to protect. And the more you put in, the better. It makes it much more difficult for them to be successful to break their way into it. It can be a little bit more challenging just because there are more steps to be done to allow actual access to that data. But in the reality, it's not that difficult, to give something that's authorized access to that data, but also deny those that aren't authorized isn't that hard. So this is really kinds of things that you want to put as many layers in as you can. Take that defense and depth approach. More is better than less. And take advantage of multiple services. Anytime I can use a managed service instead of me managing the service as a customer and letting AWS manage the service, as an example, a relational database service versus me running a database engine on EC2 myself, I'm always going to be in favor of the RDS solution just because I give AWS more responsibility to look after securing that resource and taking care of patches and making sure that it's updated and stuff like that. So anytime I can push it off to a managed service, I'm a fan of that. I'm good with that. Automate, automate, automate. So when we look at the things we do in the cloud environment, everything can be done through API requests. So AWS itself is an API-driven, resource. And the API calls can be made from the web browser. That's what we call the management console, using our command line tools, which are free downloads and install really anywhere. And of course, you could use the SDKs and incorporate those API requests right in your own application. All of these API requests can be used to automate things. So hey, if I tell you to create a VPC or set up a subnet or create a route table or launch a virtual machine, create an S3 bucket, whatever I need to do, I can do that through those API requests. Well, that means that I can then automate that. I can write a script. I can use something like CloudFormation, which allows for us to build environments. It gives us what we call infrastructure as code. We can use playbooks from System Manager. We have chef recipes and puppet manifests from OpsWorks and stuff like that. So there's lots of things we can use as a way to automate things. So when we automate things, that gives us repeatability. We can recreate this very quickly, very easily. And it gives us, the ability to, provide self-documentation. How did this get built? Well, here's the playbook we used. And we can look through that playbook and see how it was built and be able to use that as a reference point and say, okay, we missed this part here. We need to adjust that. This is too much. This is not enough. And we can adjust things if you know what it is. This is certainly, much preferred over the manual approach where, somebody, goes in and manually changes and does things. Manual is great for learning how to do things in the environment but at the end of the day, you want automation. You want to automate everything as much as you can. That gives you, the ability to, do things repeatedly and accurately. So it doesn't get changed every time you do it. And that's exactly what we want. Protect your data at all times. It really is kind of one of these things. It's your data. Keep it yours. Again, this is mostly dealing with encryption. And again, different levels and different places to do it is always there. Again, layered defense is also really good here. So client-side encryption is where you have your application encrypt the data before you send it anywhere. So encrypt the data before it leaves the application. Then take advantage of using an encrypting protocol like HTTPS, or use a VPN using IPsec or whatever, OpenVPN, as a way to tunnel the data from the application server to whoever's getting that data at the other end. And then server-side encryption, data at rest encryption, is also something you should do. So I encrypt it at the application side, client-side encryption. I send it to S3 using HTTPS. So I've actually double encrypted to transmit it. I unencrypt it from HTTPS, but it's still client-side encrypted. And then I store it on S3 and I do server-side encryption on S3. So S3 now has encryption turned on by default. So you really don't have an option anymore. It's on. You just could choose which one you like. So this is something that changed recently. So that gives us the ability to take advantage of, hey, it's going to be encrypted at rest. So it's double encrypted, the server-side encryption plus the client-side encryption while it's there. That can get us to other things as well as, who has access to the keys to do the client-side encryption would, again, allow you to limit access to that resource. You kind of think of it this way. I got sensitive HR information that's being stored in that S3 bucket. My administrators of the S3 bucket need to be able to manage the bucket. Of course, they can see everything in the bucket and change properties of the bucket, things like that. But I don't want them to be able to see the information in the actual object itself. So client-side encryption and prevent that key from being visible to the admins. So I can manage the bucket, but I can't see the data in it. So that gives us that level of separation. So using client-side and server-side together, perfect. That's a great way to do that. Classify your data using tags. We talk about tags in pretty much every class that AWS does, and it really is. It's a tool that is underutilized. You have the ability to apply up to 50 tags per resource, and to be honest, you really should. Put as many tags into play as you can. It can be useful for management of the resource. Can be useful from the financial side of things, keeping track of what things are used for which projects and life cycle and stuff like that. But it also can be useful on the security side of things. And hey, this is secret, top secret, confidential, restricted, public information. The tags are yours. You use them whatever way it makes most sense. Again, as we said, don't do unencrypted communications. Do everything through a TLS-based protocol or a VPN of some sort. And that way, again, the prying eyes can't see anything. And that's ultimately what we want. Things go bad. We know this happens. It's not a fun thing. It's kind of one of those realities of our world. The evildoers of our planet have way more time to come up with ways to try and wreak havoc in our world than we do to have to resolve them. So as soon as we figure something out, as soon as we fix something, they're out trying to figure another way to come in and wreak havoc in our world. So that means that at some point something will go wrong. Something will not be happy. It'll be a day when something didn't go the way it should have went. So this is something that you need to be prepared for. And there's a lot of monitoring services to help us out with this. Amazon Detective, Guard Duty, Macy, and a few other ones are out there as ways to monitor for things that have gone sideways. They aren't working the way they're supposed to. Take advantage of using those, and then use these as ways to trigger, hey, something went wrong. Somebody compromised the system. They installed software that shouldn't be there, malware, Bitcoin mining software, whatever. And you need to take those actions. Again, we talk about this in the security engineering classes. Things that you need to prepare for. How do you isolate it? How do you capture the information without compromising it, and so on and so forth? These are all things that need to be done. So we need to plan for that. You can't just hey, by the way, we think this thing's broken, and then kind of guess at what we need to do. And this is something that you need to game day. You need to plan for this, and that's really what that's all about. Is come up with your plans, your strategies, test them, make sure they work. And then when something does go wrong, you can take those steps and say, hey, okay, I know how to do this. I isolate my resource. I need to, put this into play, trigger this, trigger that, and get those things happening that allows us to capture that information and, of course, get that system offline as soon as possible. And, of course, mitigate those risks. Mitigation really means, how did that happen? What was the steps that the evildoer took to compromise that system? What can we do to prevent that from happening again? And again, that can kind of go back to, guard duty, config rules, and things like that can be very helpful. And hey, we've seen these, patterns in the VPC flow logs that tell us that they're trying to do something like this, and then put, ACLs into play or security group rules into play, or employ the new firewall appliance and have it do, the blocks on those type of packets and stuff like that. And be able to stop those things from happening. Again, that process to isolate the incidents and restore operations is ultimately very critical. You need to really, focus on that and get it ready to go before it happens. You don't want to do this, when you've got a system that's compromised already. Minimize the attack surface. So if I deploy, 100 web servers on the internet, I've got 100 targets that need to be protected. I need to keep my eyes on 100 moving targets. And of course, any one of them could be compromised at any point. And of course, then, depending on what the compromise is, that might end up meaning my whole fleet is then compromised. And that really is the problem. So what can I do to maybe minimize that attack surface? And one of the steps might be to put those behind a load balancer, let the load balancer be the front end. So instead of 100 web servers available to the clients, I've got a load balancer service that stands in front of them, which may be only 2 or 3 or 4 systems and that are facing the evildoers, and they actually act as a barrier between those evildoers and my backend services. So that can be a really good way to do that. Take advantage of managed services. So CloudFront's another great example of this. Using CloudFront, which is our content delivery network, our CDN, it again acts as a barrier. The clients talk to the CDN, to CloudFront, and then CloudFront talks to the backend services. The clients actually can't talk to the backend; they can only talk to CloudFront. So that really means as AWS has to, deal with the attacks and everything else at their level, and it should be fairly clear sailing from there back to your resources. Again, there are extra things you can do with that. Take advantage of API gateway. And again, you could still have a load balancer between CloudFront and your backend services. And again, more layers is better. And so use them all. CloudFront, load balancers, and firewall appliances. Put as many things in there as you can to prevent those evildoers from making their way through. If you have to expose it to the internet, it has to be there. Make sure that you lock it down as much as you can. Don't leave ports open that don't need to be open. Hey, I might need to be able to SSH into this at some point to be able to do this. Well, might need to be able to do it versus I have to be able to do it is not the same thing. So, if it's an EC2 instance, maybe take advantage of, System Manager and use that as a way to access that resource instead of using SSH and leaving the SSH ports open and stuff like that. So there are ways to lock the resources down and minimize that exposure as much as possible. So that gets us really to a good question, which is, what is your security posture? And that really is going to get us some more talking points to look at. So we've got a number of things we're going to look at. We got our 6 targets that we want to talk about. So we're going to start off with the one at the very, very top, the authentication. So when we look at identifying who you are, and again, this can be done in a couple of different ways. The authentication for access to the account, managing the account resources, but also authentication to log into your application itself. So there's, again, its authentication can be in 2 places. We're kind of focusing on the AWS side, but it can be for both. So what is authentication? It's identifying who you are. So this could be a name and a password, preferably maybe name, password, and a 2-factor authentication or multi-factor authentication approach to it. And use that as a way to, again, prove you are who you say you are. So here's my name, here's my password, here's my MFA, 6-digit code. And that, is enough information for us to say, yes, you are who you say you are. And we now know who you are. That's the first part. So whenever we look at an API request from AWS, that's the very first thing we have to do is identify you. If I don't know you, you're not getting anything. Our default permission is deny. So if I don't know you, deny. So you're not going to get anything with if you don't authenticate. If you authenticate, the next piece we need to do is, of course, identify what permissions you have. So from IAM, Identity and Access Management, again, managing access to the AWS account resources is what this is all about. This service is free. There's no charge for using this. It allows you to manage, up to 5,000 users per account. You can organize them in groups if you wish. And as I've alluded to already, take advantage of roles as a way to provide job, description of job duties, et cetera, et cetera. When we look at logging in from the management console, like I said, it's username and password, or username, password, and MFA. And again, MFA is optional. I kind of wish it was mandatory, but it is optional. You should make it mandatory for your account, really should. If you're using the command line tools or using the SDKs, we use keys, and the keys work almost the same way as a username and a password. We have an ID key and then a matching secret key that kind of goes with that ID key. They're generated together as a set. You present those keys as your identification information. That will link you to exactly one user in one account. And that really is the same as the username and password from the management console. It's a keys instead of names and passwords. That's, of course, what's going to be used to identify you. That's the authentication piece. The next piece is the authorization piece, which is, do you have permission to do this? And of course, once I know who you are, the next piece is, well, what is it you're trying to do? So I look at your API request. What API request are you trying to do? And then assess whether you're going to be allowed to do that or not. So when we look at it, we're going to look at a number of things. So the first step, obviously, is the authentication. Like I said, that's the who are you? Need that first. Then I'm going to say, well, what is it that you're trying to do? And the access request, that's the API request that you're trying to implement. I want to create an EC2 instance, for example. I'm going to launch an EC2 instance. So I'm going to look at policies, and these are all JSON-based policies. They can be any number of these in many, many different locations, from 0 to tens, hundreds, maybe. This could be any number of policies as we look around, what it is you're trying to work with. So I can have policies associated with you, the user. I have policies associated with any groups that you belong to. I can have policies on the resource itself. So I'm trying to do something with S3. I can have a policy on the S3 bucket that determines yes, no, whatever. So in this case here, I'm going to gather all of the policies. It's like, put them all in a big pot, kind of stir it all up, and then I'm going to look at all the policies simultaneously. And the first thing I'm going to do is, kind of decide if this, whatever it is you're trying to do, is going to be denied or not. So the first thing I'm going to do is actually say, okay, we're trying to do something in an S3 bucket. They're going to create a bucket. So the resource is an S3 bucket. Then I'm going to look through all the policies. And the first thing I'm looking for is a deny. So if any one of the policies says an explicit deny, says, no, you can't do that, you're done. You cannot beat the explicit deny. You're failed. You can't have this. So when I look at all the policies, if I see one deny, you're out. You can't have it. If I don't see a deny, I must see an allow. So I'm going to look through all those policies. It doesn't matter how many allows there are, as long as at least one policy has an allow statement in it. you're going to get the resource. You're going to get it. So no deny, and there's an allow. You'll get the the API request satisfied. If there is no deny, but there's also no allow, you're going to get what we call the implicit deny, which really means is you don't get anything. The implicit deny is the default. Yeah, you can't have that. And of course, that's the same as the explicit one. We don't tell you why. We just make it really difficult for you to do things because you get permission denied, and that's all you're really going to get. So that allows us to again protect those resources. We identify who you are, and then we identify whether you're going to be allowed to do that or not. Monitoring is the next piece that we want to talk about. So monitoring is keeping an eye on the environment. We want to make sure that things are working the way they're supposed to. And these can be indicators of when things become compromised. So the normal CPU utilization of these particular servers is 20%. All of a sudden, they're running at 95%. So why are they working so hard? Well, that could be because maybe there's some malware or some kind of illegal software installed on the systems. We can see an increase in network traffic, and which might be an indication something's been compromised or doing things they shouldn't be doing. It can give me, status of the service or the resources that I'm concerned about. These are working, these are not working. It's the ability to be able to keep an eye on the environment. Our service is called CloudWatch, and CloudWatch allows us to really monitor a lot of things. We have a huge number of built-in, metrics is what we call them. And of course, you just look at these at any time. You can create a dashboard, which gives you a nice visual on all the things you want to see. And that can make it easier to just, kind of get that 10,000-foot view of how things are. And then, as you're working through that, hey, I want to drill into this. This doesn't look right. And then, of course, drill into it and look at more things. CloudWatch does support custom metrics, which really is anything you want. Those can come from, in the cloud resources, but also from on-prem resources. So we can install an agent on an on-prem resource and have that send stats or whatever information you need up to CloudWatch. And again, be able to collect all that information and put it in one place. The benefit of this, of course, leads us to something called alarms. So we could look at things and say, you know what? Whenever these things get over a certain percentage of CPU utilization, for example, that should be a trigger for us. That should be something we need to go look at. So I can set an alarm and say, hey, watch the average CPU utilization on these web servers. If it ever goes above 70%, I need to know that. And basically we set an alarm on that. And basically, whenever that happens, and there's a time parameter that goes with this, it needs to be over that line for like 10 minutes or whatever. When that happens, the alarm triggers, and of course you can make the alarm do whatever you want. So send me an email, send me an SMS message, trigger something like auto scaling, which is a way to automatically increase or decrease fleet sizes and things like that. So these are all great things. We talk about CloudWatch events here. This has actually changed since this slide was built. CloudWatch events has moved to Event Bridge. So there's another service called AWS Event Bridge. Basically allows us to do event-driven coding, if you will. Basically, we can watch, or again, as things happen in your account, and it's certainly things like hardware events and things like that, which are really hard for you to get to because, like I said, back in the earlier slide, you don't have access to the hardware. But to be able to know there's something went wrong, maybe with the hypervisor your EC2 is running on and stuff like that, that's where events come into play. You can create custom events in here. You can tie to a huge list of events that are available to look at. You create an event bridge rule, and basically that lets you, come up again with an action. So it's a triggered or event-driven approach to things. If this event occurs, do this afterwards. So run this Lambda function, send a message to Pete, whatever you need to do. So again, CloudWatch events is moved to event bridge events. So auditing, again, back to that compliance stuff I talked about earlier. Yeah, that's our world. We live with this. Audits happen. I need to be ready for that. So what can I do to set up my audits and stuff like that? And of course, the primary one from the account perspective is CloudTrail. So every API, request is tracked and logged in CloudTrail. CloudTrail is always on. You can't turn it off. By default, it's only keeping data for 90 days. However, like I said, when you do that an artifact compliance check, yeah, you're probably going to need to keep that longer than 90 days. So in that case, you need to create a CloudTrail trail, which will store that information in an S3 bucket for long term. Again, you control how long that is with lifecycle policies and such at the S3 side. it will track all the API requests, successful, failed, whatever. If it happened, it happens. It also tracks login failures and successes as well. So the management console, the support side and stuff like that. So it's going to track those as well. So it's all the API requests plus a few, login, failures and successes that will be recorded. These are well understood logs. There's a CloudTrail processing log that'll be available for those that want to write their own application to interpret it. You can go look at the logs directly. They're in S3, so you can see them there. Splunk, Sumo Logic, things like that are also well tuned to work with these logs. It'll give you exactly what you want. One event can give you 50 or 60 lines of information in a log file. So these are lots of information. There's lots and lots there. Encryption is the next thing we want to talk about. So with encryption, we're looking at, potentially protecting our data in rest and in transit. We're looking at things here. Is everything working all right? Hey, Miles, am I freezing up and on? I'm kind of looking frozen.
Your video seems to be, but
yeah, my display video say I'm frozen. Is the audio and the videos, the slides coming through okay?
Yeah, the audio and the slides are fine, I think.
All right, well, I'll just keep going. Maybe I'll catch up. I'm not really frozen, really, I'm not. All right, encryption, data at rest and in transit. Again, we talked about this. When we look at, managing the encryption and looking after the encryption and stuff like that, these are things that I'm just going to turn my video off and then back on again and see what happens. Maybe my camera doesn't like me anymore. All right, we'll see. All right. So things to think about. Again, when you encrypt data, you need, a couple of things to make that work. You need to select an algorithm or an application or, program that you want to use to encrypt it. What kind of keys are going to be used to, manage the encryption? Where do you put them? How do you store them? How do you get back to them? Who has access to those keys? And these are all things you need to plan well ahead of time. Otherwise, you're not going to necessarily be able to recover your data. If data gets encrypted and you lose the key that was used to encrypt it, you're not getting it back. It's not going to be decrypted. Client-side encryption, as I said, is where you encrypt the data before it leaves the application. If it's your application, of course, you can use whatever algorithms and keys you like, and of course, you're managing your keys however you want. Use a hardware device. You could use storage devices. KMS, the key management service, can store a little bit of data through custom key store and stuff like that. Server-side encryption is where the servers are going to encrypt the data before they store it. This is a case where we need to, kind of, again, manage who has access to the keys and who's, generating the keys. That's something that, of course, is there. Sorry about the video, folks. I'm not sure what's going on. And maybe my camera's decided that it doesn't want to play anymore. I'm going to stop it for just a second here and start it again just to see what's going on. No, let's oops. Sorry. There we go. I'm going to leave it like this. We'll figure it out later. All right. So there's our encryption. So let's go on from there. KMS, or Key Management Service, is our service that we use to help us with keys. Out of the box, Key Management Service that really can't store data keys. If you set up what we call the custom key store, then you can store a limited number of keys with it and be able to manage those keys from there. However, out of the box, it does not have that. What it does is allow you to choose, what kind of keys you want, symmetric, asymmetric keys. And of course, we deliver those keys to you using a TLS-based protocol, and it makes sure that you're able to, encrypt or decrypt the data. Please understand, we're giving you two versions of the key, one that's encrypted and one that is not. The encrypted version of the key is from whatever primary key you wish us to use, a service primary key or, your own provided key. And in that way, you have two variants of it, then store the encrypted key with your data. And then when you need to recover that data, send us that encrypted key. We'll decrypt it with the key that we use to encrypt it and send that back to you. And then, of course, then you can use that key to decrypt the data. Again, because it is an AWS service, it's all done through API calls. So guess what? We get to track all of this with CloudTrail. And of course, that gives you the auditing aspect. So who did what, where, and how often they did it and stuff like that is all going to be there. In transit, so again, a number of different approaches for this. Using an encrypting protocol is one way. So HTTPS, for example, SSH, and so on and so forth. These are, encrypting the data as it leaves your system. And then, when it gets to the server decrypts that data. So it doesn't really matter what's between you and the server. The data is protected between those two systems. Oh, look at that. My video finally came back. Hopefully everybody's seeing me again. Hi, I'm back. Hopefully that's good again. With that, that's one way. IPsec or OpenVPN tunnels are another way to do that. These usually work at the network level instead of the host level. So I attach the VPN to one network and then attach the VPN endpoint to another network. And then any data going between those two networks would be encrypted with IPsec or OpenVPN or whatever protocols you're using. And of course, as it enters the tunnel, it gets encrypted. Generally, it's going across the untrusted internet. And then when it gets to the other end, it gets decrypted to the other side and put back into the network. Plain text. So it doesn't really protect the network you're attached to. It protects between the two networks and that. So SSL TLS would go from host to server. VPN is network to network, and it is the way it is. We also, have, the ability to manage SSL TLS certificates through a service called Certificate Manager. Certificate Manager allows us to really do quite a large number of wonderful things. As Miles indicated a little bit earlier, we started way back in 2014. Managing certificates back then was a pain. Trying to put a certificate on a load balancer and stuff like that was like a 30-step process. And if you made a mistake in step 3, you wouldn't notice it until step 26. Of course, you have to do it all over again because it didn't work. So when Certificate Manager came out, there was a lot of us that went, whew, about time, we needed that. And of course, it's been improved on since it came out. So looks after certificates for both, the load balancers, CloudFront, and a number of other AWS services. So AppSync and things like that require certificates that will manage those certificates for you. Public certificates for these services are free. Private certificates are available as well. And these are about 75 cents a piece. However, the private certificates you can really use anywhere you want. So those aren't restricted to AWS services. You can actually use them anywhere you want. So it's a great way to, again, manage your certificates, take that pain off the plate of managing thousands of different servers with thousands of different certificates, and simplify it. Again, it can be automated, and that's the big plus. Enforce encryption only in whatever endpoints you're setting up. So don't allow non-encrypted traffic. So CloudFront, you can turn off HTTP. RDS, you can disable HTTP communications with the servers. You could do this on your own systems. Again, you just need to set that up. Have your load balancers only listen on the encrypted ports, and then put in a policy that only allows secure traffic and stuff like that. So there are ways to enforce that, and that's certainly in your best interest. Data pass. What network controls do you have over where the data is and who has access to it? And again, isolation of the resources. Don't put your super sensitive information on a public web server on the internet. It doesn't make sense. Make sure that the access is limited to those systems that need it, and only those systems. So take advantage of things like our VPCs, our virtual private cloud, where we can set up public and private subnets and provide isolation through that. Route tables, network access control lists, security groups, lots and lots and lots of things can come into there. We do have our firewall appliance now. We can do intrusion detection prevention work, lots and lots of things there. Again, it gives you a layered defense approach. The more pieces between those that are trying to see that data and the actual data, the better. Again, if you're authorized to get there, you want that to work kind of seamlessly. But if you're not authorized to be there, we want as many blocks between them and that data as we can possibly put in there. So the more, the better. So VPC security features. So the routing is one of them. Out of the box, the virtual private cloud is not accessible from the internet. It's not on the internet. You can't get to the internet can't get to you. So it really is private, just, out of the box. I need to establish, external connectivity to that VPC, and that's an internet gateway, a VPN gateway, and so on and so forth that we could attach that VPC peering and so on and so forth. When we add something to the VPC, I need to identify which subnets can use that resource from the VPC. So that's where that subnet routing comes into play, is I use that as a way to identify which of the subnets are allowed to use that external connection. So if your subnet's not configured to use the internet gateway, you can't use the internet gateway. By the way, the internet can't see you either, so it works both ways. If the subnet is configured to use the internet gateway, then of course the resources could be exposed to the internet if you wanted them to be. Network ACLs also work at the subnet level. They are firewalls that work at the boundary of the subnet. Basically, can be used to determine what's allowed or what's not allowed. It is a stateless firewall, so we do have inbound and outbound rules that need to be set up in corresponding rules just to make sure that what's allowed in is allowed out, or vice versa, what's allowed out is allowed back in. So they are very good as a boundary firewall for the subnets in a VPC. Looking after the single host or the host within a VPC is the security group. Security groups technically work at the interface level, but often cases there's only one interface on a host, so that's it's protecting the host. With security group, these are stateful firewalls. Again, the default is to deny with security groups. So unless I have an allow rule that lets the traffic in, it's not getting in. So I can use the routing, the ACLs, and the security of those 3 different layers to protect my resources in that particular subnet. So there you go. That's all the pieces that belong to that protection mechanism. Who can make the API requests, and tracking those API requests, tracking the resource usage, and of course who have access to your resources themselves. And then more into somebody being able to access your web service, for example, is the data path side of things. So what's next? Well, next up, learning at your own pace. We've got security fundamentals. There's a security essentials class, security engineering class, learning from the experts and stuff like that. Come and have some training. And of course, the ramp-up guide. So I'm going to hand this off to Miles at this point. Miles, I'm ready to send it back to you if you want.
Sure. Okay. Well, maybe I'll share my screen.
All right. Let me get out of this.
And we can talk a little bit about some of those ILT classes, because that's what ExitCertified, that's what we really excel at. So this is sort of our learning path document where we have sort of different paths for different roles. And the one class you mentioned is the one-day security essentials class. We kind of put that up here with not deeply technical. It's sort of, if you just took the one-day cloud practitioner and you were just learning about the cloud to begin with, and you wanted a high-level overview, sort of what you just did in an hour, but stretched out over a day, right? You kind of see what are the major security controls. But it wouldn't be enough to walk out and say, I'm confident I can secure, large workloads in the cloud. It's not a heavy duty class. The heavy duty class we have for security experts, that's on the second page somewhere here, is down here, the security engineering on AWS. Now that's a 3-day class. It helps really prepare for the specialty certification, right? But the way they looked at that, and tell me if you agree, Pete, I think that AWS's stance is to secure something, you have to know what it is that you're securing, right? So they expect you to have associate level knowledge of AWS. So maybe you take the 3-day architecting class, or maybe the 3-day, now it's called cloud operations on AWS class. But you get that sort of level where you could go and get an associate certification. You don't have to get the cert, but you've got that knowledge before you go into that 3-day engineering. Is that right?
Absolutely?
I'm saying what you told me.
They expect a fundamental level of knowledge coming into it. They expect you already kind of know what the cloud is, so that when we talk about the cloud resources, it makes sense.
Yeah. And so when you look at one of those classes, so here's the security engineering class. If I go look at the schedule, there's quite a few dates, because that class we run fairly often, I think. And some of them are guaranteed to run. So if I look, if on our schedule you see that GTR, that means that date is guaranteed to run. So usually it's the virtual part of the class. They sometimes will have a virtual class, and if we get enough people, the instructor will be in a training center. But the virtual part we always guarantee to run usually. So August 2nd, September 13th, 27th. Sounds like maybe every 3 or 4 weeks usually. We're running that security engineering class, and that will help you towards the certifications. So there's sort of that first level foundational cloud practitioner, and then there's the 3 associate level certs, and then the 6 specialty and 2 professional. And so for security, the security specialty, it's not for the faint of heart, right? You don't just go in off the street and write that exam. Like, you'll have to prepare for it. And certainly if you come and take, say, the architect class and then the security engineering class, you'll still have to study a little bit, but that'll get you a long ways towards being ready for one of those heavy duty certifications. So that's what ExitCertified does. ExitCertified.com is our website. Let me throw that in the chat for you, just so you have it. I imagine you probably needed that to register here. One of the things you'll see down at the bottom is, every once in a while it pops by. I actually have a slide on it right now, but right now we have a summer promo. And so you can get, basically it's $100 per day off. So if it's a 3-day class, it's $300 off, upwards of $500 for a 5-day class. Or if you're doing learning subscriptions on demand, self-paced courses, it's 10% off. We also have sort of deals if you're doing, like, if you've got a group of people and you want to do a training just for your company, you can certainly do that. Let me put that Upskill 500, actually. I guess I could probably just go there. Upskill 500, is that what it is? I found it. Okay, here it is. So you have to register by August 31st for a class that you take by, I think it's by the end of September. There's some small print. Oh, no, here it is. November 30th, you have to take the class by. But you have to register, it's the summer promo, so you got to register by the end of August. So let me just throw that whole link into the chat if you're interested in any classes, any AWS classes. AWS isn't the only thing we do. We definitely do a lot of AWS, and it's probably our biggest vendor. But we do a lot of cloud training in general. And so one of the things we've been using to kind of explain to people, what ExitCertified does, mostly it's cloud training, right? So we're partnered with the big 4 cloud vendors. So we have their official courses. We're not building the content. Pete and I are authorized AWS instructors. So we've gone through their certification process for instructors. They provide the material, we deliver it, right? And with our AWS classes, you get access to labs for 3 months. So you can come back and do the labs after class. Different vendors have different lengths of how long you can do the labs for. But what we really found was that, when an organization moves to the cloud, it's rarely just, okay, I want to get out of the data center business and I want Amazon to take care of it. A lot of times we see sort of 3 things go hand in hand. They're moving to the cloud, they're embracing the concept of microservices, and maybe embracing things like DevOps, and so we see a lot of these things go hand in hand. And so, you see a lot of logos here, but some of these are commercial vendors that we're partnered with, like Databricks or who else, Cloudera, or some of those companies. We have their official training. And then some things like Kubernetes, it's just an open source product. Anybody can hang a sign and say we do Kubernetes training. So our job is to kind of go in and make sure that we can find who's got the best of breed training in Kubernetes and provide that to you. And so we've got lots of options all around cloud. So if you're interested in any of that, you can either talk to whoever your sales rep is, or I'll put my email address in here if you have questions. You can always hit me up and I'll put you in touch with the right salesperson. Sumi asks, how many trials for each lab is available? Well, AWS switched things, so now you can try the labs as many times as you want in that 3 months. But like I said, different vendors have different things, but that's AWS. You got 3 months, as many tries Used to be you only had 3 kicks at the can. Now they've opened it up. So we call this our cloud-centric portfolio of training. It's just trying to show the breadth of what we can do. And usually, even beyond this, these are the ones we had room to fit on here. But anything cloud related is really what we're doing these days. So I put the promo in CCSP. Yeah, I guess talking about security and specifically, there's a couple of like cross vendor, sort of general agnostic certifications like the CISSP and the CCSP and say Security Plus from CompTIA. Are any of these trainings available in person? These days, I would say that most of our classes are still virtual, right? And the best way to say, yes, I'm going to be in a classroom with an instructor is if you have enough people to say, let's put on our own private. Because I don't think those ones, we used to have a few more people in, say, San Francisco or in DC. But even there, the market has changed and people don't want to go into a classroom for training. So it's almost all virtual training at this point. Unless you have a group, and that is kind of a trend we're seeing now, is that a lot of our customers, their employees are all over the place, and so they're starting to do on-site training as a reason to get people together at their site. So we'll send an instructor to you if you've got a group of people, but to make the economics work out, you've got to have at least 5 or 6 people usually. Otherwise you're better off to just send them individually to a public class. I think it does save time on the learner's end, like commuting and everything else. Let's see, was there anything else I wanted to mention? Yeah, I guess just throw up this slide about, no, not this one, the webinars. So there's some webinars that you may have missed in the past couple months. We have a bunch of AWS Discovery Days. I'll show you those. There's still a couple coming up. There was an exam prep one on Azure Administrator, so the AZ 104. It's just it was like a 2-hour thing that our colleague Tarek did, which talked about, tips on how to prepare for that exam. And then I did this one, which was sort of a public cloud comparison, comparing AWS, Azure, Google Cloud, and Oracle Cloud. So those webinars, let me go to exitcertified.com/webinars and show you what's available. I think if I just type in webinars here, we're going to get there. I think so. Here we go. And so the upcoming Discovery Days are the machine learning one. That's like I think August 2nd, and then mine. This is mine coming up next Tuesday, noon till 2. So mine's about 2 hours. They're all like slightly different lengths. This one is the one for today, which I think when you come back, a day or 2 from now, this will actually be the recording. So here's one our colleague Craig did on migration. And so if you click on it, actually it's right there. It's not even gated or anything. So you can just go and, watch that video. So it's a little bit like what you just saw. He's doing the slides. I guess we don't have a picture of him here too much, but I think they even have a transcript that you could go through. I mean, as good as those transcripts are, and they're getting better and better. So I think that was the main stuff I wanted to talk about. We talked about certification. There's some other webinars in here. There's that public cloud comparison, the Azure Administrator certification exam prep one. And then you can go back and look at our older ones as well. So there's a lot of resources there. If you come and look for training and go to AWS, that'll take you to our main AWS page where you can find, all the courses. They sort of categorized. And like I said, if you're looking for ones that are guaranteed to run, you click on that, and it just gets you down to just the ones that are definitely going to run. Even if one person signs up, it's happening. Which is a rarity in training these days. It's hard to find classes that actually run. All right. Well, I think we're a little over time, but Pete's still here. If you have any questions, you can throw them in the chat. Can I share the link? Oh yeah, that's right. I wanted to show the webinars link. Okay. Throw that one in there as well. When you go to leave this session, there'll be a little survey that should pop up when you go to leave the Zoom session. It's only a few questions. It'll ask, what'd you think of Pete? What'd you think of the webinar? And mostly it's asking like, what other things are you interested in? Because we do like to put on these free webinars. We open them up to as many people as possible. So it's not like, 8, 10 people normally in class where it's two-way communication and we want it to feel as much like a classroom as possible. But we do want to, sort of take the temperature of the room and see what people are interested in. So we ask a couple questions in that survey on the way out. So please take, a minute or two and just answer those questions. It should pop up automatically as you leave. Anything else, Pete? I don't see any questions.
No, I'm good. Covered everything I think we needed to cover.
All right. Well, good luck with AWS, and hopefully we'll see you maybe next week in my webinar or in a classroom down the road.
Good day, folks. Have a good one.
I'm going to leave it just for a second so people are copying the links from the chat. There may be a way to save the chat. I don't know if that works or not.
I have the save chat option, but I'm not sure if that's because
I'm not sure
I'm
if
a panelist or not.
Maybe just us. Yeah, I don't think they can save the chat. So you should be able to click on those links and at least open them up and then bookmark them after. Yeah, I think you're better off to just click on those links if that works. I can throw a couple of those diagrams into the chat, I think. If you can download from there, maybe. And then the AWS Learning Path document was the other one I showed, right? Yeah, I'm not sure if everybody's going to be able to get those. It really depends how your Zoom is set up. Some companies, they put real locks on the Zoom chat, so you can't save documents or even click on links from them. But hopefully you can copy those links. I only put 2 or 3. All right. Well, have a good afternoon. Bye, Pete.
Bye.